In the past, warfare took place only on land and at sea. However, with the introduction of fighter jets that attack mid-air, warfare expanded into the sky. To combat fighter jets attacking from the sky, the ground forces developed and used defense weapons such as cannons and machine guns. However, the higher consumption rate of cannonballs and bullets made them less efficient, and with the introduction of faster jets, new weapons became necessary. In the 1950s, portable surface-to-air missiles began to develop, which were lightweight and simplified the launch process. In the early 1960s, the American military came as far as developing shoulder-launched missiles. These missiles were modified and improved over multiple trials and put into action in the Vietnam War. This became the Red-Eye surface-to-air missile. The Red-Eye is an infrared-guided missile. Infrared guidance devices located on the missile head are also called heat seekers. In locations that generate a lot of heat, such as a fighter engine, strong infrared rays are emitted. When the missile captures infrared radiation that is stronger than its surroundings, it will track it and detonate the warhead within or near the heat source, causing damage. As the early Red-Eye missile had poor infrared detection capabilities, it was difficult to track fighter jets that came flying to the front. Usually, fighter jets carry exhaust vents at the back, where they blow out a lot of heat. The exhaust vents of fighter jets that fly toward the front are almost invisible. Therefore, the infrared wavelengths were also less visible. Consequently, it was difficult for the Red-Eye to detect the infrared rays of the fighter flying toward the front. Normally, it was only possible to attack the rear of a fighter jet with clearly visible heat from the engine. The Red-Eye was enhanced to compensate for these shortcomings, which led to the invention of the Stinger. Here is the basic configuration of a Stinger missile. It has a diameter of 70 mm, a length of about 150 cm, and a weight of about 10 kg. A Stinger missile is mainly composed of a guidance device, a warhead, and a propulsion device. At the front of the guidance section, there is a seeker that tracks the target. The seeker has a camera that detects infrared or ultraviolet radiation. All objects emit infrared energy. The amount of infrared radiation usually depends on air temperature. The thermal camera captures the temperature difference. Infrared radiation is also emitted from nature, in which the fighter jet flies. This includes infrared radiation emitted by the sun, sunlight reflected on the clouds or hills, and infrared radiation emitted by lakes, etc. The seeker distinguishes between infrared radiation with a small surface area from a fighter's exhaust vents and infrared radiation with a large surface area emitted by clouds or land. Except for the sun, the engine's heat is usually the smallest and hottest, so the seeker tracks that spot. The sunlight itself does not damage the seeker, but it is recommended that the seeker is pointed far away from the sun when aiming. The Stinger, which was previously only capable of infrared detection, was enhanced with the addition of ultraviolet ray detection. It can now recognize the shape of the aircraft by detecting ultraviolet rays emitted from the fighter's surface. Using ultraviolet rays allows the target to be detected more accurately than when only using infrared rays. When the enemy aircraft fires flares for defense, detecting the shape rather than the heat results in more accurate detection. The detection accuracy of the target can be improved by using infrared and ultraviolet light. Furthermore, the number of pixels on the seeker's sensor was increased compared to that in the initial stages. As a result, more detailed images are obtainable now. The seeker is installed on the gyroscope. The gyroscope can rotate in any direction. The gyroscope allows the missile and seeker to move independently. Therefore, a larger area can be detected than through a fixed seeker. Even if the enemy aircraft dodges the attack quickly, the seeker moves first to catch up with the target without missing it. In addition, the missile body of the Stinger rotates as it flies. Even within the rotating missile, the seeker can be leveled through the gyroscope. In this way, the seeker moves independently and tracks the target in a stable manner. The round cover surrounding the seeker minimizes air resistance. The transparent cover also protects the seeker from direct sunlight. Thus, it also takes on the role of improving infrared detection. Behind it is the guidance assembly. The guidance assembly uses the data measured by the seeker to calculate the flight route and speed. The calculated data is sent to the control unit at the back. The control unit has wings that change the direction of the missile. Two pairs of wings are arranged in a cross shape. Of the two pairs of wings, one pair is stationary and the other pair is movable for flight control. Normally, a missile moves both pairs of wings to move the missile up, down, left, and right. However, the Stinger missile is characterized by its management of only a single pair of wings. As the weight was reduced for its portability, the caliber of the missile was also reduced in size. The small caliber made it impossible to include all the controls that allow the movement of two pairs of wings. Consequently, only one pair is movable, and the other pair is fixed. The missile was made rotatable because it had to be controllable with only one pair of wings. As the missile rotates, a pair of wings performs the role of two pairs of wings by alternating turns. When the moving wing is placed horizontally, it instantaneously controls the missile so that it can move up and down. Then it rotates into a vertical position, controlling it to move left and right. When it rotates back into a horizontal position, it moves up and down. This is repeated over and over again. Calculations are complex because it is controlled by a single pair of wings while rotating. Therefore, the computer inside the control unit calculates the movement of the wing. Behind the control unit is a battery that provides power. The warhead section contains a fuse assembly. Approximately 450 grams of high explosives are contained within a pyrophore titanium cylinder. The fuse assembly can either detonate when it hits a target or self-detonate about 17 seconds after firing. The propulsion section consists of a flight motor, tail fins, and a launch motor. The launch rocket at the back is responsible for ejecting the missile from the launch tube. The missile is ejected until it is a safe distance from the shooter, and the launch rocket is detached from the missile. As the four tail fins unfold and the flight motor ignites, the missile begins to fly full scale. The flying rocket maintains the missile's speed and momentum until it intercepts the target. The launch device of the Stinger missile is largely composed of a launch tube with a built-in missile, a detachable grip stock, and a battery cooling unit. The missile is housed in a launch tube. The front and rear of the launch tube are sealed with discs. The disc will break when the missile is fired. As the launch tube is disposable, it cannot be reloaded and reused once the missile is fired. A side assembly is installed on the front of the launch tube, and the IFF antenna is installed on the side. The IFF antenna receives a signal that identifies the target and determines whether it is an ally or a foe. The grip stock has an uncaging switch that separates the missile from the launcher. There is a hole in the back that connects the battery cooling unit. Behind it is the firing trigger, and above the handle is a safety device. The battery cooling unit has a built-in thermal battery and argon gas. The thermal battery provides the necessary power before launching the missile. Argon gas cools the infrared detector. The temperature of the infrared detector must be lower than the ambient temperature for effective detection of infrared light. Before launching the missile, the shooter is equipped with an IFF interrogator. To use the IFF interrogator, the cable is connected to the grip stock. The IFF antenna sends a signal identifying whether the target is an enemy or an ally. IFF stands for identification friend or foe. When the IFF sends an identification signal, only registered allies can send a response. Even when there is no reply, it cannot be ensured that the target is an enemy. This is because allies often fail to respond properly. Therefore, it is used as an auxiliary when making an attack decision. It weighs about 15 kilograms, including missiles and launchers. The shooter can easily move and fire alone, but it is usually operated in a pair of two with an assistant shooter. Insert a battery cooling unit into the grip stock by turning it clockwise. Once the battery cooling unit is activated, it only operates for 45 seconds, so the missile must be fired within that time frame. Then, unfold the IFF antenna. Remove the cover on the front of the launch tube and raise the side assembly. Connect the cable from the IFF interrogator under the grip stock handle. Capture the target with a side assembly and aim the launcher toward the target. When aiming, aim at the launch angle within the default of 10 degrees to a maximum of 65 degrees. Press the IFF interrogate switch directly above the handle to request identification of whether the target is an ally or a foe. The subsequent response is a beep sound that is delivered via the acquisition indicators located next to the side assembly. When a response confirms the target is an ally, a beep occurs for 0.5 seconds, stays silent for 0.5 seconds, and then another beep occurs for 0.5 seconds. If the response is incorrect or no response is received, short beeps will occur in a row. This means it cannot be confirmed whether the target is an ally or a foe. When the shooter puts his or her eyes on the side assembly, the bone conduction device installed next to the scope will naturally come into contact with the shooter's cheekbones. That is how the sound is transmitted directly through the cheekbones. Bone conduction devices are used in wartime when beep sounds cannot be heard accurately due to the sound of cannonballs or gunshots. Once the foe identification is confirmed, the target is kept and tracked within the front range ring visible on the side assembly. The side assembly consists of a range ring at the front of the launch tube and a rear side assembly reticle at the back. The rear side assembly reticle has 3 small grooves. If the target is flying from left to right, locate the target within the range ring and align it with the left groove of the rear side assembly reticle. Conversely, if the aircraft flies from right to left, aim by overlapping the groove on the right side of the rear side assembly reticle. If the aircraft flies in front or vice versa, match it with the center groove of the rear side assembly reticle. When the aim is complete, use the right thumb to lower the safety and actuator device to activate the missile. The seeker in front of the missile captures the infrared rays of the target. When the infrared of the target is clearly detected, a beep is heard to inform the shooter. After confirming that the missile has captured the target, the shooter presses the uncaging switch on the grip stock. The uncaging switch disconnects the missile that was under the control of the launch device, allowing the missile to operate independently. Keep the switch pressed while continuously tracking the target. While holding the disconnect switch, pull the trigger. The trigger must be held down for 3 to 4 seconds. The trigger then activates the missile's battery. When the battery is activated, the launch motor is ignited within 0.5 seconds. The ignited launch motor burns briefly inside the launch tube and is extinguished. The missile is fired by breaking the disc in front of the launch tube. As the missile exits the launch tube, the two movable control surfaces and tail fins are unfolded, and the launch motor is separated. The missile ignites a flying rocket when it flies to a safe distance from the shooter. With the propulsion of the flying rocket, the missile accelerates to Mach 2. As the missile passes through Mach 1, the remaining two fixed wings unfold to stabilize the body of the aircraft. The missile has a maximum altitude of about 3 kilometers and an effective range of 4.8 kilometers. A missile can destroy a target just by flying and hitting it at Mach 2, but the high explosives in the warhead amplify the effect several times. The BCU gets very hot after use and must be removed immediately after launch to avoid damaging the grip stock. The grip stock can be used to separate the missile from the exhausted launch tube and then used again for other launch tubes. The Stinger, a leading model of portable surface-to-air missiles, became famous for shooting down numerous Soviet helicopters during the Soviet-Afghanistan War in the 1980s. In the recent Ukrainian-Russian war, there was even an article that mentioned a Russian surface-to-surface ballistic missile shot down by a Stinger missile, and it is still active in 2022. These days, Stinger missiles have been upgraded to air-to-air missiles and are being utilized in various platforms, such as being installed on attack helicopters or launched from vehicles. That's it for Stinger missiles. Thanks for watching.